Hey, this is Mr. Dan with Touch Technologies. Today we're going to talk about strings here and under the hood, which means we're going to be talking about the parts of string data that you don't just see when you're writing code. When you're writing code, you do things like, $a equal quote Sam quote or things like that, really simple. But under the hood, a lot of things happen. String data is used everywhere in business applications. People's names, addresses, documents, web pages, data from tables, these are all strings. Sheerpower processes strings really fast. They're designed as follows. We have a string variable, which then points to what's called a fixed data area, which then points to a thing called a string descriptor. This may be something new to you. It's also referred to sometimes as the metadata for the string. And part of the string descriptor then points to the string in memory. The string descriptor contains the length of the string, which you're familiar with strings, and a pointer to the string in memory. It also contains a globally unique ID, and this is something that's a little different with Sheerpower. Each unique string constant and string variable has its own GID, globally unique identifier. When doing string assignments, if two string GIDs match up, the assignment can be ignored because their GIDs match, therefore they represent the same data. Now they're going to be most likely in different locations in memory, these two strings you're comparing, but their GIDs are identical, which means that the string data they represent is identical. You can kind of think of it as a string hash, but it's not a hash, it's a unique identifier. If two string GIDs match, the assignments can be ignored. This speeds up code execution a lot because having to do some kind of string manipulation is much faster than doing it. So here's an example of Sam, which is a string constant. And string constants also have their own fixed data area descriptors, and in this case a GID. In our little example here, the GID, again, globally unique identifier, is going to be 1, 2, 3, 4, 5. The GID gets assigned at compile time, so when the compiler sees, $a equal quote Sam quote, it knows that Sam is a string constant. It then sets up a descriptor for it, points to the word Sam in memory, and assigns a GID to it, which in this case is 1, 2, 3, 4, 5. At runtime, okay, this is when your program is running, at runtime, $a equal quote Sam quote, the variable $a then gets some memory allocated to it, so it has its own string descriptor. It then receives a copy of Sam, but it also gets in its metadata, which is part of the string descriptor, Sam's GID of 1, 2, 3, 4, 5. If later we say $b equal $a, all right, what happens? Well, what happens is that $b gets a copy of $a, not a pointer to it. I know things like Python point to these things. We do not, because of some things having to do with garbage collection issues that we avoid. $b equal $a, and now $b now has a copy of $a data, and it also has $a GID of 1, 2, 3, 4, 5, which, if you recall, is also the GID of Sam. Okay? They all represent the same data. Not the same data instance, because they're in different places in memory, but they represent the same data. Okay, so $b has a copy of $a data, and it has the GID of 1, 2, 3, 4, 5. Later you say $c equals $b, okay? $c has a copy of $b data and is given $b GID again of 1, 2, 3, 4, 5. Later on in the code, at runtime, $a equals $c. Now $a and $c have different memory allocations in different memory areas because of their string descriptors, but they have the identical GID thereof 1, 2, 3, 4, 5. Therefore, the copying of $a equals $c, this becomes a no-op. Sheerpower knows that since the GIDs are identical, even though their data is located in different places in memory, the data instances match exactly, and therefore Sheerpower is able to avoid this copy of data. This happens at very, very low levels within Sheerpower and greatly speeds up almost all string operations, because programmers are accidentally assigning things values that they've had before quite frequently. So thank you as always for your attention on the under the hood of strings. We'll be doing another tutorial later on memory allocation, how Sheerpower uses memory and reuses it and avoids memory allocates and deallocates and other things that are also related to these strings. As always, subscribe and leave comments, ask questions. We know that this method of using these GIDs is unusual, and we're happy to hear your feedback. Thank you so much.